Okay, so now we move on to step 3, which is the analysis stage. Okay, so part A of this is get that standard deviation of the population, of the sampling distribution, excuse me. So that's sigma over square root of n. Sigma is 7. Square root of n is square root of 10. Okay, let's do that calculation here. Let's get out a calculator. So see, I need I'm going to go to the scientific calculator for this one here. So 7 divided by 10, hit the square root sign. Where's the square root sign on this thing? Oh, shoot. If anyone finds the square root sign, just holler. Let's see, where's the square root sign? Jeez. Well, the standard one has a square root sign. Okay, let's just start over here. Okay, 10. Square root of 10, 3.16. So I'm going to have 7 divided by 3.16. 3.16, 2278. That should be good enough. Okay, now I'm going to divide 7 divided by that square root of 10, 3.162278. Okay, that equals 2.21, and I'll round this off here. 2.21. I'm not too picky on rounding. I'll just say 2.2136 should be good enough. All right. So there is our standard deviation. Now, back to our problem here. Standard deviation is about 2.2. So I can see here that my x bar is roughly 1 standard deviation higher than the null hypothesis here. So anything that's about 1 standard deviation from the mean, that's a fairly likely event. I'm probably going to end up accepting the null here. But let's go ahead and do the math. Let's finish it off here. So second step in the analysis is get that z-score. So z is the mean here, 27.4 minus the null hypothesis, which is 25. We want to know how far is that sample mean from that null hypothesis, divided by the standard error, 2.2136. By the way, the formula that the author gives you a formula. It's your same old z-score formula that you learned about a long time ago, but we can use different notation here. It's x bar. It's the sample mean minus the null hypothesis. So you could say mean from the null hypothesis right there, divided by that standard error of the sampling distribution, which is sigma over square root of n. So it's the same z-score formula, but just we're changing the symbols around a little bit. Okay, so anyway, let's do that calculation. Let's clear out the old thing here. So 27.4 minus 25 equals 2.4. Divide that by 2.2136, 1.08. All right, so z equals 1.08. All right, well that is almost for sure I'm going to end up accepting the null here. But step 3, let's go ahead and go through the routine here. So get your p-value. So the whole idea here is my normal curve, my sampling distribution is a normal curve. 25, assuming the null is true, 25 is right in the middle. 27.4 is up there. I want to know, oh, by the way, one more thing. The alternate hypothesis is greater. So that's telling me that I'm looking up the upper tail of the sampling distribution here. So what is the area of that part of the curve? In other words, what is the probability of getting 27.4 or higher from a sample of size 10? Okay, so we got the z-score already, 1.08. So let's go to the table in the back of the book and look that up here. I'm going to pause for a minute while I get the table going. Okay, I found the table. So let's so our z-score here is 1.08. So let's go here to here's the table. So find 1.0 on the left of the table. This is page 677 of your textbook. 1.0 and then find 8, the 08 here. So 0.8599. Now, of course, we have to subtract from 1 there. So our p-value here is 1 minus 0.8599. Let me double check that number here. Yeah, 8599. Okay, and that is, now subtracting from 1 because I'm looking at the upper end, upper tail up there. So that is equal to 0.1401. So there's about a 14% chance. So bottom line here is if the null really was 25, if the untrained noses were just as good as the trained noses of 25 micrograms per liter, then there's about a 14% chance of getting the result we got, of getting that 27.4 or higher. And so that's a pretty high p-value. So step 4 is a conclusion. So if the p-value is less than alpha, which I predetermined to be 0.05, then reject. But in this case, I'm not rejecting it because p-value is pretty high here. So in this case, I'll say otherwise you do not reject or fail to reject, whatever phrase you want to use. Okay, so that's the decision in this case. Do not reject the null. So to write your conclusion in plain English, you would say something like this. There is not evidence. There is not evidence that we can go back to the let's go back to the original question here, which was here it is. The question was, is there evidence that the mean threshold for untrained tasters is greater than 25 micrograms per liter? Well, the answer is no. There's not evidence because p-value was too high. So the mean threshold for untrained tasters, so back to our original, so there is not evidence that the mean threshold for untrained noses, basically you can just repeat the question and just say yes or no, there's evidence or not evidence for your final answer. That the mean threshold for untrained noses is greater than 25. Okay, now maybe it is. Maybe it is really greater than 25. Maybe the real population mean is 28 or something. But the evidence is not there. Our p-value was just too high. And so we just have to go with there's not evidence. And that's it for that question.